Hello everyone, I am Anshriti and today I am going to take you through an interactive analysis of a specific age distribution trend in the USA using data from Google's Data Commons. I'll walk you through how different interaction techniques can enhance our understanding for this dataset. So let's begin. First, we can see a chart showing the age distribution in United States from the year of 2021 to 2023. As you can see, the population is in the 5 to 17 age group has the highest part. Although this data set might be large, it's hard to see the distribution over many years. So we can use a timeline tool to explore this data further. Now we can see a timeline graph that shows trends over the past 10 years period across all the ranges that we saw earlier, how they increase, decrease, or stay stable. I can even filter the data manually by selecting a specific age group that I want to focus on. If I want to focus on the population aged from 5 to 17, I can manually change that. You can also add a new age group from the sidebar over here if you want. But let's focus on just one. Even though this might seem a little limiting, so let's reconfigure this data into something more visually engaging. If we switch it to a map explorer format, this data is now represented into a heat map by states. This allows us to visually see the California data has the highest population of this age group in 2023, while Vermont has the lowest. But if we see the data set over here, you can see that District of Columbia has the lowest. For that, we might have to zoom in. Okay, as we saw, this is how the data is encoded visually. The highest population is represented into a dark red color, while the lowest is represented into the lightest shade of gray. Now let's abstract this data and scale it to a more detailed level. So instead of looking at the data set by states, let's zoom in into its county level. Okay, this might seem a little bit messy at first, but we can focus on a specific region. Returning back to California, we saw, which had the highest population, by the way, we can now see that Los Angeles have the highest population count of our age group at 1.5 million. This number corresponds to its darker visual in the map shown earlier, which is because of the highest concentration of this age group into this particular county. Now let's get back to the state view. Okay, now if we want to understand the connections between different trends, we can even connect different related data from our sidebar. Okay, we can see many variables. For instance, I'll add disability status to see the trend related for hearing difficulties within this age group. So this shows many people in the age group have hearing difficulties across the state. Like California has 33.8K and Texas has 32.4K. To make it even more interesting, if I turn on the per capita filter, we can see a clear trend. This filter shows that the percentage of people with hearing difficulties relative to the total population of that particular stage. So for instance, Wyoming has the highest percentage of people with hearing difficulties in our data range. Similarly, if I want to explore something else, for, say, vision difficulty within our age group, which results, as I can observe, that Mississippi has the highest percentage of people with vision difficulties with our age group, which is 0.32. So, by using these techniques of tagging, exploring, reconfiguring, encoding, abstracting, filtering the data, and even connecting the trends, we can gain a better understanding of a complex data set and uncover insights that might not be visible to naked eye. Even though I chose a particular data range, you can even explore many data ranges from the data set to make it more interesting. So, thank you so much